Hi everyone. Today we will discuss about importance of tracing and tracking in both monolithic application and as well as microservices based application as well. Imagine you have an application with multiple modules. Consider this is as a banking application or any e-commerce application, okay, any healthcare application. I have my application here. While end users are using it, consider they are doing fund transaction, or they are purchasing an item in e-commerce, or when they are buying a insurance from the insurance application. They had a problem as a end user. They found a problem here. They got some exception or issue, and they called to customer care and informed, hey, while I am doing fund transaction, something got failed. My amount is debited but not credited into the opponent party, and it is not even deposited back to my account. There is a problem happened. When they report to the customer care, they will raise a issue and that will be assigned to development team. As a development team, how we can find out that problem, how we trace it? Usually we do logs in our application, right? Usually we do logs in our application. Using log file, we can able to understand, okay, if there is an exception from our class, we record that log into log file, right? Errors or when a request come to your method, when request is completed, during exception scenarios, in all such scenarios we keep information into logs. So as a development team, we ask production people or production team, give me logs for so and so time. Yesterday some users try to request or some users try to do fund transfer, they got failed during between morning 9 a.m. to afternoon 12 p.m. there is a issue happened. If development team, if they ask production team for the production logs, right, they will provide production log. As a development team, we should read that production log and we should understand where the problem is, so that we can directly go to that particular class where we have that problem occurred, and we can verify what is the problem and we can fix it. So it is not a big deal in monolithic architecture finding the problem and fixing it. But imagine a microservice architecture. We don't have single application, right? In microservice application, multiple modules will be implemented as a multiple microservices. In such scenario, when end user reports a problem, as the development team, it will be very difficult to us to identify the problem. So there should be some tools or APIs or libraries to help us to minimize that findings, or as a developer easily to find the problem and resolve the solution. In microservice architecture, we have some tools. Let's see what we have. Yeah, if you see microservices architecture, we will not have a single application for all our modules, right? We will be having so many applications. We will be having so many microservices. As a end user, when I do something from front end, let's say I'm doing fund transaction, or I'm purchasing an item from the web UI. As an end user, I started finding items and I'm placing the order using microservices. Consider you have multiple microservices in the backend. First, my request going to microservice 1, and microservice 1 is sending request to microservice 2, microservice to microservice 3, 3 to 4, and 4 to 5, 5 to 6. So your request is spanning across multiple microservices. Your one single request going across multiple microservices. As a team, microservice 1 team, you don't know about microservice 2 requesting whether microservice 3 or 4. You don't know that. As a microservice 1 team, you will be having a dependency of microservice 2. So you are usually placing a request to microservice 2. Microservice 2 team may have the dependency of other microservices. Exactly, it may not the dependency cycle as I am showing here, but more or less your microservices may have interdependencies. One microservice may call another microservice. Now here in this situation, Imagine when there is a problem, as an end user, right? I placed a order, it is going to microservice 1, then microservice 2, microservice 3, it is going till microservice 6. There it is failed. There it is failed due to some exceptions, or there it is waiting for too long time because there is a bad code or a bad data structure we have, or some connections busy, something, a problem occurred in microservice 6. So we should able to find out that problem. So end user will report, okay, I tried to place a order and it took long time, finally cash is debited but order properly not placed, there is an exception happened. When they report to dev team, now dev team, they don't know, they need to refer whether microservice 1 or microservice 2 or microservice 3, which microservice logs they should verify. When exactly they don't know the problem, how many teams need to involve to understand the problem here? There is a problem occurred, okay, fine, but in which microservice I got that problem? That will be very difficult to trace it. That will be very difficult to trace it. Usually, right, we will record logs. Let's say if you are using Azure, maybe by using App Insights kind of tool, we record logs. And to trace it, what you can do, if you can integrate Zipkin across your microservices, if you can integrate Zipkin across your microservices, what will happen when you place a request? When it hits to microservice 1, if you can use a Sleuth here along with your implementation, if you can use Zipkin with the Sleuth API, what you can do, if you just add Sleuth API and Zipkin into microservice 1, when your microservice 1 place request to microservice 2, then 2 to 3, 3 to 4, when this request chain is happening, what will happen in the backend? Your microservice will generate some IDs like parent ID, trace ID, right? Like that, it will generate some IDs and it will record that IDs, right? It will generate IDs using Sleuth API, and those records it will send to Zipkin server. You need to start a Zipkin server. Okay, so your microservice will record all the trace into Zipkin server, so that we can easily able to identify, let's say as a user, Pawan requested microservice 1, and then microservice request going to service 2, service 3, service 4. All your requests trace will be recorded into Zipkin server. I placed a request to microservice 1 requested to service 2, service 3, service 4, service 5, service 6. When your services flow across multiple microservices, all that flow information will be stored into this Zipkin server. So just by logging into the Zipkin server dashboard as a developer, right, easily I can trace where the problem is. I can see the complete flow diagram, I can see the complete flow information, including the how much time it spent to complete that request, right? I can easily see which microservice called which microservice from there, right, one point to another point, how the flow is happened, everything easily I can observe and I can understand the problem. Okay, I'll show you example. I'll create 3 microservices and show you example how exactly it will record. First you need to start Zipkin server. Just download the Zipkin server jar file. Okay, it is a Spring Boot jar file only. So download Zipkin server jar file and just open it in command prompt. Okay, just open it in command prompt and run this command. You know, right, how to execute jar file. Java-jar, give the Zipkin exe jar and --. I want a port number which I want to execute into 9595 port. I want to execute this server. Just run it. When you start it, automatically Zipkin server will start. You see, this is the Zipkin server, it is getting started. So you can see Zipkin server getting started in our port number 9595. So finally Zipkin server is started. Zipkin server started in port 9595. You can see visually how this dashboard, Zipkin server dashboard, looks like. Okay, let me show you that. Yeah, here you can see the Zipkin server dashboard. If you see Zipkin server dashboard, right, I just uh, entered localhost 9595 Zipkin, then it is showing a dashboard view here. If you observe this dashboard here, right, it is given some buttons also here, find traces, service names. If you have multiple microservices, right, when you integrate, it will show all that microservice names here. And you have such option also here using trace IDs, right? You can enter your trace ID here and you can click on search so that it will show you all the trace information. Okay, so if you click on find trace, if there are any traces, right, it will show you. As of now there is no trace, so that we can't see any information. Let's implement microservices and integrate with this Zipkin server so that we will see the complete trace. So here I have three microservices, service A and service B, service C. I am using a Zipkin server with Sleuth across all these three projects. I am going to show you the flow between service A to service B and service B to service C. The complete flow I will show you now here. What I have added as a dependency during this project creation, I just included here in my POM file, right? I just included, if you observe here, I added Zipkin server and Sleuth dependencies. You can see them here. I added Zipkin server dependency and Sleuth dependencies. Those two are enough. Okay, those two are enough along with your other dependencies. Like it is a just simple REST application I am creating and sending request from one service to another service. That's why I just included web here. Okay, and coming to properties, there are no much properties. Just open properties file. Okay, I am running my service A in 9091 and my service application name is app, and the Zipkin server, whichever we executed now, right, the Zipkin server is running in spring.zipkin.base URL. I have given Zipkin server URL here, http://localhost 9595. Why I given this Zipkin server path here in this application? When my microservice A request any other microservice, right, it will record that trace into your Zipkin server. Okay, similarly I implemented service B, service C. What kind of code I have here? In service A I have implemented a REST class. I have implemented a REST controller here, a REST controller with a simple HTTP get method. You can see here, simple get method I have. When someone call my application A, what I am doing here, using this REST template, right, I am calling REST template dot get object, create REST template dot get object. So this get object method, okay, let me show you this get object method calling localhost B service which is running in 9092 and getting response back. Here you can see the response back I am getting here, and this response I am just appending to A response plus B response adding here. Similarly, if I open service B, same thing I am doing in service B as well. So if I open service B running in 9092, and I have given Zipkin server path, and here also I implemented one controller, REST controller, and implemented method B method which is calling in A service, So here again I am calling using REST template get object, I am calling service C. If you see here, I am calling service C also from B. I am calling service C here, which is running in 9093. And finally I am appending response here. Finally I am appending response to B response plus C response. The same thing is implemented in service C as well. If you go to service C, Yeah, I have finally implemented a service C method. Here just given C call and implemented C response. So when A calls B, B will call C and C will give response back to B. So finally this response will go to B and B will give this response. B will give this response including B response to A when A calls it, right? When A calls it, A calls B and B calling C. Finally B response and C response appending to A, and that we are returning when someone calls A call. Okay, now let's run three services. And see how this tracing will be recorded. Okay, I am running service A. Service A is getting started. You can see service A is getting started. Now run service B as well. And service C. Three services I am running. Service B also getting started. You can see service B getting started here. Now let's see service C also. I am running service C as well. Service C also getting started. Okay, now three services started. Let's test it. I will call A flow will go to B, and B call C microservice, and we will see where this flow or your trace is recording. Really, is it recording into Zipkin or not? How it is recording? Let's understand. Okay, let's understand how it is happening. I'm opening here browser localhost 9091. A service is running in 9091 and the URL is A call. Let's run it. Okay, call is executed. So this is A response. A calling B service. From B I am getting this response including C response. B calling C. So C response appending to B, B response appending to A. Finally I am getting response here. Now just go back to your Zipkin server and click on trace. Click on trace here. You will be seeing this trace information. When you click on trace, right, here you can see a service is executed in 914 milliseconds and the service is executed 3 microservices: A app, B app and C app. If you can click on this, right, if you can click on this, you can see the tree kind of structure in which sequence they executed. A called B, B called C, and how much time they have taken also clearly you can see here how much time each has taken. So C finished execution in 201 microseconds and it given response back to B, and B completed its request in 562 microseconds and it is given response back to A, and A finished it finally 914 microseconds. So the entire response A given back in 914 microseconds, so that we can see where it is lagging, which microservice taking how much time, easily we can understand. And as I said, Sleuth will record IDs here, right? How Zipkin is able to finding or creating this tree? Is the Zipkin is having such a intelligence? Yes, but how that intelligence is prepared, how Zipkin server is able to finding them in a row, A to B, B to C, how it is understanding that. So if you click each microservice, right, if you open each microservice, you can see some tracing IDs which are generated by Sleuth. I opened service A, and when I click on this show IDs, observe here, 3 IDs got generated: trace ID, one ID generated, remember this ID, and a span ID. This is service A, okay, and parent ID. Service A itself is a parent. There is no parent for service A, is the first one that we executed. So one trace ID is recorded, span ID is recorded. Okay, trace ID is common across all the services. A called B, B is calling C. If C calls D, D calling E, same trace ID it will use. Okay, span ID belongs to this particular service A. Okay, this span id belongs to service A and same trace id also. Okay, as it is the first service executing. Now if I open B also here, you see this is service B, B call is executing, show IDs here, B service IDs. If I click on show IDs, right, it will show here trace ID, same trace ID which is generated in A also. Span ID is different. Span ID belongs to this particular B service, and parent ID is your A service ID. A service span ID becomes parent ID here. So it is clearly putting your trace ID, span IDs and parent IDs to understand who is the parent of each microservice, so that it can construct in a order, in a tree order it can construct, or it can show you which services are executed. Even if I open C app, right, you will be seeing the same trace ID, a different span ID, and the parent ID is the span ID of B service. So we can understand who is the parent for C call and who is the parent for B call. For each service we can understand, using this parent IDs, we can understand who is the parent for this call. Okay, so this is the trace ID, right? Using this trace ID also you can able to apply search here, as I shown you here, right? You can go to this trace option, enter this ID, click on search. So even when you perform that, right, you will see the search result here. You can see the search result here. You can see even in that search also it is showing the result here. So this is how Zipkin will help you to understand. When there is a request from one microservice to another service, how it is executed, how much time taken, right? That all easily we can able to trace it out, and we can identify the problem also. So for the same execution, let me create an exception and restart it, so that we will see the problem also reporting or not. I am just shutting down my C microservice. Okay, let's shut down C microservice. I'll create intentionally a problem in C microservice. I'm just shutting down C microservice. Okay, C microservice is down. Now let's test it. Let's open the browser. So intentionally I shut down C service. Now let's make call to A. So I'm making a call to A. Definitely I'll be getting a problem here, because there is no C service running. A service going to B, B is going to C, C creating the problem. Okay, how I can trace it out, right? If you can just refresh this Zipkin dashboard. Okay, find all traces here, click on find all traces. You can see the latest trace information which is executed less than a minute ago. This is executed less than a minute ago, it is executed, so that easily I can able to trace it out. So if you click on this, right, you can see the problem. There is a app, B app, and there is no C app. And why it is showing red? If you open B app call, got error, right? It is showing got error. If you click on this, it will show you clear error description also here. So it is showing 500 error. When I make a get call from B, what is happening? IO error, get request to HTTP localhost 9093 C call, connection refused. Obviously there is no C services running, so that we are getting connection refused and we are getting the problem. So clearly it is describing what is the problem also. I made a request to C and the C service is not running, that's why the problem is creating. So by looking into this, anybody, even a fresher, can understand what's happening in the system. They can understand what's happening in the system by looking into these color codes, right? By looking into these errors, easily we can understand what kind of problem is occurring and we can address the problem, right? So this is how Zipkin is going to help you to trace the problem, and easily we can able to understand the problem and we can fix it. So if I go back and run it, if I go back and start the C microservice, I just came back to C microservice. I'm just getting started. So I understand the problem. Now as a developer, by looking into the dashboard, I understand which microservice got failed. So I am just restarting my C service. So C service is getting restarted. C service is getting restarted. I'll just go to browser and verify it. I just came to browser and just re-request it again. Now my request is completed. I'll go back to Zipkin and once again I'll verify. Once again I'll verify whether there is any problem in the current request or not. I'll click on find traces. So less than a minute ago, very recent request I can see here. Here I have 3 minutes ago request, 9 minutes ago request, and less than a minute ago request. The very recent request is completely into green. It is completely into green and executed in very less time, 121 microseconds. So if I open it, I can see all the healthy responses. I can see here the written healthy response, so that I got the response properly. So this is how easily we can identify the problem and we can fix the problem, right? We can address the problem and we can resolve the issues. If I don't have such a tracking system, it will be very difficult to understand the problem and addressing the issues. Okay, so in that way Zipkin is helping us a lot to understand the problem and finding the solution in microservice architecture. So finally Zipkin is helping us. Via Zipkin dashboard we understand that how microservices request spanning across multiple microservices and where the problem is occurring, and we can easily able to figure out the solution, right? Easily we can able to figure out the solution in our microservices architecture. Easily we can able to understand the problem when there is a request spanning across multiple microservices where the problem is, and we can address that issue and we can resolve it, right? So it is very important in microservices, finding the problem, tracing the problem and fixing it. Thank you all.